So in this problem, you're asked to illustrate or show how this data illustrates the law of multiple proportions, which is Dalton's proposal that when you have two elements that combine to form compounds like A, B, and C in this data table, then the way that they combine in all the various ways that they can combine, if you have one, so another way to describe this law of multiple proportions is if you have 1 gram of one of the elements, then in all the forms of the compounds, the other element will always be multiples of a whole number. Let's illustrate that, or let's show how this data illustrates that. So all the ratios we can form here in compounds A, B, and C is A to B, A to C. Actually, let's just do this one at a time. All right, so A to B. Okay, so you can plug that in your calculator and it's going to be 2 to 1. That's a 2 to 1 ratio between A and B of the nitrogen component. So that's what this table is showing us. Now let's go A to C. A little more easier to see is B to C. So let's do that. B to C, between these two compounds, there's twice as much nitrogen by mass than the nitrogen in compound C. So hopefully you can see that between A and C, I'm just going to go over here. Actually, let's pick up. So between A and C, right, because A to B is 2 to 1 and B to C is 2 to 1, then A to C is 4 to 1. And again, you can plug in your calculator that smaller number in compound C of nitrogen will go in 4 times into the amount of nitrogen in compound A. And these are the only 3 combinations you can make: A to B, B to C, and A to C. No matter what you do, you're going to get a whole number. You got 2, 2, 4, and so this illustrates the law of multiple proportions. If you didn't get whole numbers, then you would say the data does not support the law of multiple proportions, but in this case it does.